Hi all, I am creating this short video to finish up section 6.3. Okay, so let's jump right into it. So the last thing we talked about is how to show a given vector field is conservative. So there was two ways to do this. First one, if f is path independent and it is continuous and the domain is open and connected. Remember, path independent means the integral does not depend on the path, it only depends on the end points. If you have these conditions, you can say f is conservative. The second way is if the vector field obeys cross partial property and the domain is open and simply connected, then f is conservative. Now the most useful is the second one, because it's easier to show the cross partial property than showing the path independence. Okay, so we will be using this to show a field is conservative. Okay, we did one example, but let me go through it again. Example number 34. Is this field conservative? Now it is defined everywhere. So since these are just polynomials, so defined area, so open, simply connected, all the properties are there. Now we need to check whether it obeys cross partial property. So p sub y, is it equal to q sub x? And p sub z, is it equal to r sub x? And q sub z, is it equal to r sub y? Since we already did this, I'm going to use the second equation. P sub c, the partial derivative with respect to c is x y squared. Is it equal to r sub x? Partial derivative of r with respect to x is 0 because there are no x terms. Now as soon as we have this, now they are not equal, therefore the cross partial property fails. Cross partial property fails, so it is not conservative. F is not conservative. So the answer is actually no. Alright, so we did this example. Let me go to the next example. Is f given by this is conservative? Right, so let me label them p and q. Now the domain here has restrictions. Okay, so the second term q has a denominator. So by just looking at q, I can say y cannot be 0. The denominator cannot be 0. By looking at p, I can say the domain of Ln is positive numbers. So y needs to be positive. What this says is your domain is everything above the x-axis. So this is the x-axis. Y greater than 0 is everything above x-axis. Now this is an open, simply connected, right? So this domain is open and simply connected. Okay. Now if we have this open and simply connected, we only need to check the cross partial property. P sub y, is it equal to q sub x? Partial derivative of the first coordinate with respect to y is x times ln becomes 1 over y. Q sub x is x squared becomes 2x over 2y, which is x over y again. Okay, so they are equal. Yes. Now at this point we can say the truss partial property holds and D is open and simply connected, therefore F is conservative. The cross partial property holds, so F is conservative. The answer is yes. Okay, I think we did this example too. Let's move to the next example, example number 36. Okay, our goal is to evaluate this integral where f is given by this formula and c is a smooth curve from origin to 1 1 1. Okay, now to do this actually we need conservative property because they are not specifically saying which curve to pick. Sorry, they are not say, they have not given what c is exactly, so it is a smooth curve. So let's check first whether f is conservative. If it is conservative, let's find the potential and use the fundamental theorem. Right? Now each and every coordinate, so let me label them. This is p, second coordinate q, third coordinate r. Now they are nice function, polynomials and exponentials, all are entire defined everywhere. So the domain is R cube and it is open and simply connected. So no issue there. Let me write it. D is R cube, open and simply connected. Good. Then let's check cross partial property. P. So since we have three variables, we will have three equations. P sub y, is it equal to Q sub x? So let's find P sub y. 2x eyz plus a 0, is it equal to Q sub x? It's 2x eyz. Yes, they are equal. So therefore this is true. Second cross partial property, Pz, is it equal to Rx? P sub c, derivative of p with respect to c is 2x ey plus ex. Is it equal to R sub x? Third component with respect to x, 2x ey plus derivative of ex is just ex. Are they equal? Yes. Therefore the second equation is also true. The third property is qz, is it equal to R y? Q sub c is this. Is it equal to R sub y? Is x squared ey? Yes, they are equal. Therefore all the cross partial properties are true. Now this says, actually this says f is conservative. if f is conservative, we should be able to find the potential. So let's find the potential. Now to find the potential, we use P is f sub x, little f sub x, Q is little f sub y, and R is little f sub c. Okay. Now f sub x is 2x eyz plus exc. Integrate with respect to x to obtain f. 2x becomes x squared. The second term, integral of ex is just ex plus a constant. It is a constant with respect to x, so it depends on y and z. Then I'm going to differentiate it with respect to y. Ey is just ey. Second term will disappear, and this is derivative of c with respect to y. Now we know f sub y is the second coordinate x squared e y z. Now combining these two, we get x squared e y z is equal to x squared e y z plus c sub y. So we get c sub y equals 0. Okay. Derivative with respect to y is 0. That means it's a constant. So c is a constant with respect to y. Now that means it only depends on c. Now at this point we know f is x squared eyz plus exc plus c. Now instead of c, we found it is a function of z. Now let's find the third partial derivative with respect to z. First one, it's x squared ey. Second one, ex. And third, d prime. And we know the third component. So on the top of the page, we see it's x squared ey plus ex. So f sub c is x squared ey plus ex. Now combining these two, we get x squared ey plus ex equals x squared ey plus ex plus d prime. D prime equals 0, so d is a constant, just a number. Therefore, we find that f is actually x squared eyz plus exc plus a constant. Now we have a choice. We can either keep it as an arbitrary constant, but let me make it 0. So we found what the potential is. The question asks us to find the integral, which is the difference of potential values at corner points. You plug 0, 0, 0, you get 0. 1, 1, 1, you get 2e. So the answer is 2e. Okay. Right. So the only new thing we saw in this is you have to first show it is conservative to start to begin with looking for the potential. Okay, now this is the last example for the day and for the section. It's a physical application. Let F be given and it's a force field. If a particle at origin moves to 2, 3, okay, so they are telling at the beginning it's here, at the end it's at 2, 3. Find the work done. Now we don't know what the path is. So since we don't know that, our guess is this might be a conservative field, so we don't need the actual path, we only need the endpoints. The domain is R2 because they are nice polynomials, so no restrictions. So open and simply connected. So let's check the cross partial property. P sub y is it equal to Q sub x. P sub y is, okay, let me write what P is. P is this, Q is the second coordinate. P sub y is 2x times 2y, so it is 4xy. P sub y is 4xy. Is it equal to Q sub x? 2 times x squared becomes 2x, y is 4xy. Yes, they are in fact equal. Therefore, the cross partial property is true. So, F obeys cross partial property, so F is conservative. Now, okay, the work done is the integral, right? So work done is the integral. It is the vector line integral. To find the vector line integral, we need to first find the potential. Okay, so now let me go back. First coordinate is f sub x, second coordinate is f sub y. So we get f sub x is 2xy squared and f sub y is second coordinate 2x squared y. Integrate with respect to x, you get x squared y squared. So sorry, f equals x squared y squared plus a constant with respect to x. That means it depends on y. Differentiate with respect to y, you get 2x squared y plus c prime. Now using these two, we get 2x squared y plus c prime equal to 2x squared y. So c prime equals 0, meaning c is just a constant d. At this point, we know the potential is x squared y squared plus a constant. Now the work done is the integral by the fundamental theorem. It's the f of the terminal point. Terminal point is 2, 3 minus the initial point 0, 0. Plug 2, 3, you get 2 squared, 3 squared. Plug 0, you get 0. So the answer is 36. Okay, so that's it for this section, and this is the end of this short video, and I will create more videos for the next few sections for the Monday and Tuesday of the next week. And if you have any questions, feel free to email me. Yes. Okay, bye.